So we ended with file 4 here. Let's open up file 5. So we extract him. He pops up. He's a Rhino file again, or at least he's a CAD file. And those of you might be wondering, why not use AutoCAD? It's because AutoCAD does not have a programmatic interface that we can utilize. And there we go. We see a frowning face again, which makes you potentially think, oh, great, I can just go back and I can use my original script, no problem. This is easy. But again, it's all about what's our first instinct. Yes, to you it looks like a frowning face. To the computer, what is it? So let's investigate a bit here. Let's see if we could just kind of justify using this first one, which said the mouth was a curve. Uh-oh. Now the mouth looks like two things. It's represented by two things. And those of you in the AEC industry will know this happens a lot. This is a very typical thing. This is an elliptical arc now, and it looks like it's two arcs. So, again, to us, file 1, 2, and 3 looked exactly like this pretty much, other than some small rotation issues. But data-wise, it's changed once again, and we have to go back to the input-output board. Let's go back to what we originally said at the very, very beginning of our foray into the smiley face example. On a very, very high level, we have said that the input is an unhappy face, which could range anything in between this situation and this situation. And there were 3 types of options for us getting this done. We could rotate the existing smile, we could mirror the existing smile, we could draw a new smile. Now, in this situation, all 3 are still going to be valid. We had preferred before to rotate the existing smile. And let's stick with that situation for now, just for the purposes of seeing how what looks like a very small change in data will have an impact on our original script. Keeping in mind that originally we had a picture that looked like this. Yes, it might have been drawn maybe like this, but that was files 1, 2, and 3. And file 5 now is looking very much like our original one, except for, and I'm going to exaggerate it here, to your eyes it doesn't look like that, but to the computer it definitely is, that there's curve A and curve B here. Now again, let's keep the continuity of saying our job is to rotate it, but how does that change our script? So let's go back to the drawing board and do it from first principles. So the input is, again, the global strategy. Let's see if I can pull up the original one. Our original global strategy, where was it? Here it was. Hasn't changed. For option 1 of the algorithm, rotate the existing smile. If we remember that, rotate the existing smile. We said, great. We're going to do something where we select the mouth and we rotate the mouth. Period. Yes? That hasn't changed. What has changed is the version 2 of this script. So technically we have to say the computer sees now one big circle, a couple small ones, something that looks like this, something that looks like this. And these guys are not necessarily in that order. The output, again, is to sort of have these guys formulated such that we're seeing this. And we know that effectively, if we're going to maintain the rotation scheme, that is going to need to be a little bit looking more on the microscopic level, something like that, where there's 2 separate curves there, right? So I guess, what are we going to do? What's our main algorithm here? We kind of have already gotten into the habit of saying step 1 is select the mouth, yeah? Something like that. So what does that actually look like in this one? We actually know that that's actually manifests itself as, okay, I have this and I have this one, yeah? And we already know how to do that in Grasshopper, which is great. And then number 2 is rotate the mouth. And at this point, we know that we've had problems with this before, and we've never really dealt with having 2 of them at once, right? So I guess the good news is we have to remember kind of all the pain that we did last time was about effectively knowing that if you have this and you can get to this, right, and you can give it 180, that effectively, you know, it can take it and it can take it to this side and actually yield for you something that's like this. So the question is that still a valid methodology if we had this guy or this guy? Because remember, they're 2 separate things now. So it's really an issue of if it works separately, then it maybe can work. So if there was a point here, yeah, and relatively speaking, the same point here, just like, so this point would be these guys. Again, the computer doesn't care that we see them next to each other and we interpret them as a mouth. The computer does not care. So to the computer, it's 2 separate problems, and there's a point here and a point here. Again, 180, 180. Let's see here. Logically, would that work? So if you did 180 over here, you flipped it around, what would that mean? You'd have one here. If you took this guy and you flipped him around 180, you'd end up with this. Yeah, so together that could work. So really, the algorithm itself is still working for us. It's just an issue now of how do we deal with the fact that instead of it being one item like it was before, how do we deal with it being a list? And this is a key thing when you're first starting off, is you've got to start scaling up, going from doing one thing at a time to being able to do multiple things with one script, let's say. So let's go see if we can do that in Grasshopper.